Alright, good day everyone. So welcome back to my YouTube channel, Kasiligan Vlogs. And today we will be talking about circular disk method. So this is one of the methods in computing the volume of a solid revolution. So circular disk method, this is a method is useful when the axis of rotation is part of the boundary of the plane area. So in this case, so this is part of the boundary of the plane area. So we have here when the axis of rotation is the axis and the top of the plane is given by the curve y is equal to fx between x is equal to a and x is equal to b, the volume of the solid of revolution is given by this one. So take note that in circular disk method, it is always perpendicular to the axis of rotation. So meaning to say that when the axis of rotation is x, so therefore the functions that we are solving or integrating is in terms of x, because this is the distance here from a to b, that is our dx. This is the limit from a to b, and the functions or integrations or the functions that we're going to integrate class is dx. So tanang mga functions ana dx na tanan once the rotation is in axis is revolving around x-axis. All right, so this one, we're going to think of this that this is the length. So this is the length. Of course, this is perpendicular to the axis of revolution. Revolution or rotation is the axis of the top of the plane given this one. Again, if the axis of revolution is in the x-axis, so meaning to say our function is in terms of x. So volume is equal to pi integral of y squared dx from a to b. So that's it. So we're going to take note again that when the function is the axis of rotation or revolution is in the x-axis, so therefore all function shall be solved in terms of x, and this one is the length of the strips. So this is the area that we are going to get, but we need to get only the strips here to represent, and the summation of that one will be from a to b. So the next is that when the axis of rotation is the y-axis on one side of the plane, our the plane area is given by the curve x is equal to gy, and between y is equal to c and y is equal to d, then the volume of the solid of revolution is given by volume is equal to pi x squared dy from a to b. So take note, the axis is an y-axis, so therefore our functions or the functions that we're going to integrate is in terms of y, because the axis of rotation or revolution is in the y-axis. So this is Rx here. This is the length of the strips, and this is the width of the strip. This is dy. So take note that these strips, length of the strips, this is perpendicular to the axis of rotation. So this is what we call the disk method. So when the axis of rotation is in the y-axis, all of the functions that we're going to integrate is in terms of in the y-axis is the axis of rotation, all of the functions that we're going to integrate is in y, or in terms of y. If the axis of rotation is in the x-axis, all of the functions that we're going to integrate is in terms of x. So that's why here the formula is that is dy, because this is the width and this is the length. Okay, so this is the length and this is the width of the functions, or the strips rather. Okay, so let us have problem number 1. Find the volume if the region is bounded by the curves y is equal to x cubed, y is equal to 0, and x is equal to 2, and is rotated about the x-axis. So the first thing that we're going to do is we need to find the point of intersection. So when the point of intersection given here, y is equal to x cubed, y is equal to 0, and x is equal to 2. When x is equal to 2, y is equal to, when y is equal to the function y is equal to x cubed, we're going to substitute. So therefore, y is equal to 2, 8. So this is 1. And when y is equal to 0, y is equal to x cubed, that is cube root of y, cube root of 0, that's equal to 0. So therefore, this is in the origin. So here, the axis rotated in the x-axis. So therefore, we know that it is rotated in the x-axis. So the functions that we're going to integrate is in terms of x. So this is the formula in finding when this is in terms of x. V is equal to pi y squared dx, integral of y squared dx from a to b. So take note of this one, that this is the length y and our width is dx, that is perpendicular to the axis of rotation. When the perpendicular to the axis of rotation, so therefore the functions that we're going to integrate is in terms of x. So now pi is equal to pi times y squared dx from a to b. So how we're going to know the limit or the boundaries? Since that is in terms of dx, so we know already that is in terms of dx because the axis of rotation is in the x-axis. So therefore, the limit is here from a to b. So, mo ni ang ginagmay class, kini ang ginagmay. Mo ni ang strips niya. So, kini di ay padung ani mauna ang atong boundary. So from 0 to, sa man boundary ani, this is the boundary is 2. So therefore, from 0 to 2, mao ang atong boundary. So 0 to 2. And what is this, the value for y squared? So the value for y squared, or the value for our y function, because this is the length. Okay, the length. And this is our dx, the width. So the length function is y is equal to x cubed. So the formula is y squared, so we need to substitute x cubed, then squared. So this one is x raised to 6. So pi and the x raised to 6 dx from 0 to 2. So we need to integrate now. So this will become x raised to 6. This will become x raised to 7 over 7. So pi from 0 to 2, because we know already that the boundaries is from a to b. In terms of x, so therefore the functions of intersection is from 0 to here, 2. Because what we're going to get here is this area. Okay. The volume of this one, or the volume rather, the volume of this one. So here, pi x raised to 7 over 7, we're going to substitute it, the value. So 2 raised to 7 over 7 minus this one is 0. So therefore, 128 over 7 minus 0, that is 128 pi over 7 cubic units. So that's it. So very simple, because this is just a simple integration. So the thing that we're going to do here is we know how to find the what is the boundary. Okay, what is the boundary from a to b, and whether that one is in terms of x or in terms of y. The function be in terms of x or in terms of y. And this y squared is the length of the strips. Okay, so that is in terms of, and our width is in terms of x. So therefore, that is in terms of x. So therefore, we have to substitute the value for y as x cubed here. So that's it for example number 1. Let's proceed with example number 2. Find the volume if the region is bounded by the curves y is equal to square root of x is equal to 0, x is equal to 4, and it is root rotated about the y-axis. So here it is rotated in the y-axis. We know already that when it is rotated in the y-axis using the circular disc, that is the function that we're going to integrate is in terms of y. So the first thing that we're going to do, class, is we need to get the intersection first. So that is what we're going to do. And next is to have the graph, and we need to apply the formula, or we need to plug in the formula. So given y is equal to square root of x is equal to 0, and x is equal to 4. So when x is equal to 0 and y is equal to the square root of x, y is equal to 0, square root of 0, y is equal to 0. So therefore, the functions here is 0, 0. And when x is equal to 4, the function y is equal to square root of x, y is equal to square root of 4, y is equal to 2, that is 4 over 2. But you could make use of ordered pairs, class, in illustrating. So we could have, this is the parabola opening to the left, right, or upward or downward. So we could imagine. But this time, so we need to first get the intersection of this one. So 0 and 0, 0 and 4, 2. Since the rotation is about the y-axis, class, so we rotate siya, no? Rotate here in the y-axis. We know already that the rotation is a y-axis, and these strips is found part of the plane area. So therefore, this one is our width here. So this is our width, and this is the length now. So if this is the length, so by volume is equal to pi from C to D, pi squared dy. So what is the limit here? So the limit or the boundaries is from, since in terms of y, 0 here from 0 to 2, because this is y. From 0 to 2, that is the limit here, 0 to 2. And what is the value for our x here? Since that is in terms of y, we need to substitute the x here in terms of y. So therefore, the value for our x is, okay, this one. The value for x, y is equal to square root of x. Since we need to get the value for x, so x is equal to y squared, because we're going to take the square of this one. So therefore, x is equal to y squared. So they plug in y squared, then squared, that is dy. So pi integral of 0 to 2 y squared, then quantity squared dy, that is y raised to 4. And we need to integrate this one. How to integrate? Use the basic rule, that is y raised to 5 over 5, because you are going to add 1 plus 4 plus 1 over 5 from 0 to 2. So we are going to plug in now. So we have here 2 raised to 5 over 5 minus 0 over 5 over 5. That is 32 over pi. So V is equal to 32 pi over 5 cubic units. Again, when we talk about circular disc method, so that's attached here. Okay, attached, and is perpendicular to the axis of rotation or revolution. So that's it. So we know already when the how to determine whether it is in terms of x or in terms of y, and how to get the boundaries. The boundaries is the reference for this one is pwede mag-google on here. You will not be confused. So if that is dy, so our boundaries is here in y, in terms of y. Okay, that's it all about circular disc method.